Hello everyone, let's solve another problem. Triangle ABC has AB equal 21, AC equal 22, and BC equals 20. Points D and E are located on AB and AC respectively, such that DE is parallel to BC and contains the center of the inscribed circle of triangle ABC. Then DE is equal to m over n, where m and n are relatively prime positive integers. Find m plus n. Okay, so this is one of these geometry problems that I typically either struggle with or find tedious and annoying. But of course, we're going to start with a sketch of a diagram and just see if we can put together all the information and figure out a good approach. Okay, I think I've incorporated all the information we have here. Yeah, so DE, this line segment is parallel to BC, and the center of the inscribed circle is on the line segment DE. So essentially, we need to find the length of the line segment DE. And based on the way the question is phrased, it's a rational number. I guess a natural thing to do probably is to draw... is it going to be the case for sure that the point of intersection here, do I know which side of D it's going to be on? Like obviously the diagram I have here is not drawn to scale. So those three connections are probably worth making, and maybe also drawing from the center of the circle to these three vertices. I think it is correct to say that this point has to be, it's on the correct side of this intersection. Well, let's say the radius of the circle is r. I'll start with that. Like, it's just like not even interesting, a question like this. Is there a formula for how to find the radius of the inscribed circle given the side lengths? There is, right? I have no idea what it is, but I'm sure something like that exists. We're parallel to BC, right? BC is the shortest side. I'm going to draw somewhat of an exaggerated diagram. So if I can find this radius, this is 20, 21, 22. If I can find the radius, will I be done? I'm not really. Like, am I really going to set up an equation with this many variables? What the... y squared is equal to f squared plus r squared. X squared is equal to r squared plus b squared. And z squared is equal to... Oh, wait. Hold on. Okay. E is equal to D, right? We have two triangles. Those lengths are the same. That's a shared side, so E is equal to D. Okay, so we can relabel some of these sides at least. All right, hopefully this will get us there. Whatever. Completely change the letters. That's A and A. This is going to be B and B. And here we have C and C. These are from where the radii intersect the sides. Okay, so let's set up. I want us to try and solve for r first of all. And then see what we can do from there. I don't know if this will allow us to do so, but let's just go for it. Okay, so y squared is equal to r squared plus b squared. X squared is equal to r squared plus c squared. And z squared is equal to r squared plus a squared. But we also have a plus c is equal to 22. B plus c is equal to 20. And a plus b is 21. Okay, so we can solve, hopefully we can solve for a, b, and c in this system of equations here. Let's write this out a little neater. Okay, let's make sure that I didn't make any mistakes and these satisfy these equations. A plus b gives me 21. A plus c gives me 22. And b plus c gives me 20. Okay. Now, we substitute these in here. If we sub in there, we'll have x, y, and z in terms of some constant along with r squared. Okay, so this doesn't allow us to solve for r exactly. We have 3 equations and 4 unknowns. Is there another piece of information we could use? We have not used yet that this line segment is parallel but I mean, the reason I want to solve for r is then, I mean, it's not exactly if I had the height of the triangle like this, and if I had r, then the ratio of this side to that side we could figure out. In theory, we can find the height of this triangle, right? A little bit of trigonometry. I mean, yeah, I haven't done anything using the fact that we're parallel here. I just don't even, if I were writing this contest for real, I would skip this question immediately for 2 reasons. 1, because I'm not good at them, and 2, because I don't enjoy doing them. Whatever. I'm happy leaving it here. I don't even whatever. I don't know what to do next. I don't even want to try and figure out what to do next. I'm just going to end this one here. If you want to make some suggestions in the comments about how to do this, cool. But I'm going to move on to another one that's more interesting.